we want to graph this relation and determine the domain and range and whether or not it's a function. So let's first assume that you do not recognize this relation and you don't really have any idea of what the graph will look like. So when in doubt, you can always make a table or a t-chart, if you want to call it that, and just decide on some input values, some x values, and we'll generate a table of values and then plot those points. So always a good idea to kind of start from -2 to 2, and we'll see if those are enough values or if we need to expand our table. So we're just going to input -2 for x, so 2 times -2 is -4, plus 3, and my output is -1. So go ahead and pause the video and make your table. So at -1, inputting -1 will give you +1. Inputting 0 will give us 3. +1 will yield 5. And +2 will yield 7. So let's plot those points and see what the graph looks like. So here are my points, with the exception of the last one, which wouldn't fit on my graph. And now you may look at this and go, oh, I recognize that this is going to be a line. And you're right. But before we just go ahead and connect and extend and put arrows on both ends, let's make sure we're really certain that we should include arrows. For example, if you were to just connect these points that I have here, we would have a line segment. And it might seem like kind of a trivial point, but it's actually pretty important to ask yourself if this line deserves arrows. In other words, does it continue in both directions forever? And that goes back to asking yourself about the domain. What are all the possible values that x is allowed to take on? And in this example, you could include any x value that you wanted. So even though in my table I only went from -2 to 2, we could have included smaller values like -3 or even like -100, and we could have included much larger values if we had wanted to. So it's because the domain of this function, the domain of the function is the set of all real numbers. That's the reason why we can say we're confident that this line is going to extend in both directions forever. So it's not just a line segment, it's actually a line. And our domain is going to be all reals. Remember, in terms of notation, you can write that from -infinity to +infinity. Some people will write it x is an element of this interval. So you may see it written that way using your element symbol. Or you may see it in set notation, which is written as the set, all values of x, such that x is an element of the real numbers. So this notation here, this is called set notation. And you're using kind of the fancy R, which represents the real numbers. So a couple of different ways of writing that. And then from our graph, we can also determine the range. So remember, the range are all the possible y values. So you're thinking about the lowest point on the graph and the highest point on the graph. But again, because this graph goes down forever as well as up forever, it also has a range of all reals. So again, you can just write -infinity to +infinity, or you could write y is an element of this interval. That would be fine too. Now, perhaps when you first looked at the problem, maybe you did not make a table of values at all, and that would be perfectly fine. Perhaps you recognized that this was a line from the beginning. And if you didn't recognize that, then it would be helpful to go ahead and maybe include this review, that lines can be written in the form y equals mx plus b. We call that slope-intercept form. So remember, the m value is what we refer to as the slope of the line. That's going to be the steepness of the line. And the b value, that's our y-intercept. You can think of it as b stands for begin if you want to. If that's the y-intercept, that's the value when x is equal to 0. That's our y value, our corresponding y value. So if you had wanted to generate this graph using your knowledge of slope-intercept form, you certainly could have done so. You would start with your y-intercept. So we have a y-intercept here at +3. And then our slope is 2, which is really 2 over 1, which is telling me that we're going to rise 2 units, and then we will be going to the right, or run, 1 unit. So starting at the y-intercept here, at positive 3, the coordinate would be 0, comma, positive 3, then we would be traveling up to, try that again, sorry. Okay, up 2 units, up 2, and then you'd be going right 1, and you can go see that it would land you then at the next coordinate. In addition, if you wanted to go the opposite direction, still maintaining your slope of 2 over 1, then we'd be going down 2, which is the negative direction. Therefore, we'd have to go left 1, since a negative divided by a negative will give us a positive, and we ultimately do want to have a positive 2 for our slope. So we could also then go down 2 and left 1 and land on my next point, and do that again, down 2, left 1, and land on my next point, and that would be using slope-intercept, the slope-intercept form of the line, in order to graph this line. Lastly, is it a function? Remember, to be a function, for every input, there is only one output. Graphically, that means that your graph must pass the vertical line test, and the answer is yes. This line does pass the vertical line test, so it is a function.